Welcome to the CIPM and BIPM joint online workshop on the International System of Units in Fair Digital Data. Fair meaning findable, accessible, interoperable, and reusable. With this workshop, CIPM invites us all to contribute to the development of its grand vision for a digital framework for the International System of Units through discussions and hopes to achieve consensus on the next steps. My name is Merit Malmqvist Nilsson, and I'm going to chair this plenary session together with Dr. Robert Tanish, who will be the moderator of the discussions. I have, as a background, a master's degree in electronics engineering with focus on wireless technology in medical measurements. A major part of my 43-year career, I have worked in SWEDAC, the Swedish National Accreditation Body, in various management positions. When I retired 2018, I was the acting director, and I was also the chair of Ilac. I have worked with the development of national, regional, and global quality infrastructure systems, have chaired various committees within EA and Ilac, led over 30 peer evaluations, participated in trade negotiations, and was the first chair of the new network INET-QI for the global QI institutions. Our moderator today for this plenary is going to be Dr. Robert Tanish. Dr. Tanish is the director of the Office of Data and Informatics, Material Measurement Laboratory, the US National Institute of Standards and Technology, commonly known as NIST. His team provides data management and data sharing solutions for the organizations and manages the NIST portfolio of standard reference data. He is a member of the Research Data Alliance Council and chairs the CoData Task Group, Digital Representation of Units of Measure. He earned his PhD in astronomy at the University of Maryland, studying extended radio emission in clusters of galaxies. Next slide, please. At this point, we have our keynote speaker and the person who is going to welcome you and give us the background. Our plenary session will be opened with a joint welcome from CIPM and BIPM, given by Dr. Wynand Liu, the president of CIPM since March 2019, and currently responsible for the development of a CIPM strategy for 2030 and beyond. Dr. Wynand Liu has a background in solid-state physics and nuclear diagnostics. He has held leading positions within metrology at national, regional, and international levels, and has been instrumental in the establishment of AfriMets. Also, representing the BIPM at this opening plenary, I would like to welcome Dr. Martin Milton, the director of the BIPM since 2013. And please.
Good day to everyone around the globe. It is my pleasure, Dr. Wynand Liu, President of the International Committee for Weights and Measures, the CIPM, to welcome you to our workshop this week on the International System of Units, the SI, in Fair Digital Data. The pandemic means that we must have this workshop online, and I'm speaking to you from my home base in South Africa, and I've heard that more than 700 of you have registered for this workshop. I hope that you enjoy this week with us, and thank you for giving us your time. I quickly need to introduce our organization to you, as I realize that not all of you are from the metrology world. It started in 1875 when 17 industrial nations signed the Meter Convention in Paris and introduced the metric system as a global measurement system. To date, 63 states have signed the convention, and another 40 states and economies have joined as associates of our General Conference. On the map on the left, you can see the countries belonging to our system, and they basically represent 97% of the world economy. The CIPM then developed the Mutual Recognition Arrangement for NMIs to compare their national measurement standards. And to date, 262 institutes have signed the MRA. We have conducted more than 1,700 comparisons of our national measurement standards, and based on the results of these, we have published 25,000 calibration and measurement capabilities of the participating institutes. And laboratories can now interrogate this key comparison database kept by the BIPM if they need traceability or to show accreditors assessors where they get their traceability from. We also established a regional metrology organization system to help us to manage this whole CIPM MRA, but you will hear more about that later during the week. So back to the metric system that evolved over time and in 1960 was renamed as the International System of Units, the SI, with the 6 base units defined in terms of physical constants. In 1972, the mole was added for amount of substance. So during this time, a lot of redefinition took place, and for example, the meter was redefined in terms of a fundamental constant, the speed of light. But one problem remained. The kilogram was still defined in terms of the international prototype of the kilogram held in Paris. And if you signed the meter convention, you obtained a copy of the IPK, and that became your national standard for mass, and you had to take it back to Paris to calibrate against the IPK periodically. So in 2018, on advice of the CIPM, the 26th CGPM agreed to change the definition of the kilogram, ampere, Kelvin, and mole. So in the revised SI, we fixed the values of the 7 so-called defining constants. And now, for example, for mass, you can use this value of the Planck constant to realize mass with a kibble-watt balance anywhere on the globe, independent of the IPK, and it just did away with the IPK. The same conference also elected the new CIPM. We are elected every 4 years, basically, and we, of course, work through the International Bureau of Weights and Measures with their Secretariat headquarters in Paris. At our first meeting, we decided to develop a strategy 2030 plus. And those 3 points basically introduce the whole idea of that we must get involved in the digitalization. So we want to respond to evolving needs for metrology and address key scientific challenges to advance the global measurement system, and we want to do it with other international organizations. So the CIPM established a task group on the digital SI with Joachim Ulrich as the chair, and they established the international expert group with representation from across the metrology globe. And directly after this, you will hear from him on this. The CIPM also established a joint task group with the International Organization for Legal Metrology, the OIML. And our main strategic objective is to develop and promote a common vision and a common holistic concept of metrology as a key element for the active promotion of the quality infrastructure concept. And this joint task group shares the aim to establish a framework that meets FAIR principles and includes stakeholders in the quality infrastructure, whilst of course respecting member and stakeholder privacy constraints. And we welcome and encourage stakeholders in the international measurement system and quality infrastructure to participate in the establishment of this digital framework. With that, please enjoy the week with us, and we are looking forward to your contributions and input.
Thank you, Dr. Liu, for this opening welcome and for the insights you have given us as to how the meter convention was developed. Now, the next part of our plenary consists of a number of speakers. So after the opening insights of Dr. Liu, there will be speakers who will set the scene for the workshops to take place during this week on the International System of Units in fair digital data. Our speakers will provide us with the opportunity to hear reports of achievements and strategies from organizations in the international quality infrastructure. We shall also hear about actions that are undertaken within various leading organizations regarding data formats, interoperability of data, FAIR principles, and artificial intelligence. We shall also have the opportunity to understand some of the major developments in science related to the transformation of data into a digital world. The presentations are pre-recorded and they will be played in the order given in the program. The recordings will be made available for you at the workshop platform around a day after the end of this session. Please also note that you can forward questions and comments on the presentations through the chat facility. After the presentations, there will be a short discussion session where our moderator, Dr. Tanish, will read some of your questions live, and the presenters will be given the opportunity to answer them live. The remaining questions, which have not been answered during the discussion session, will be collected by the workshop committee, and arrangements will be made to forward answers to these questions to all participants after the workshop. Please note that the discussions at the end of the plenary will also be recorded and made available later. At this stage, in order to have a proper flow of the workshop, we would like to introduce all of our speakers in the beginning, and then you will be listening to their pre-recorded videos one by one. The first to speak will be Joachim Ulrich. Joachim Ulrich has studied geophysics and physics. He has held leading positions in universities in USA and Germany. He has been a director at the Max Planck Institute for Nuclear Physics in Heidelberg. Since 2012, he is the president of the German National Metrology Institute, PTB. In 2012, he also became a member of CIPM and was elected vice president of the CIPM in 2015. He is also the president of the Consultative Committee for the International Units and chair of the CIPM task group on the digital SI. He has published numerous papers and received several awards. The next speaker will be Mark Wilkinson. Dr. Mark Wilkinson is the Fondation BBCBA Chair in Biotechnology at the Technical University of Madrid. His institution has worked on fair biomedical data for many years. Dr. Wilkinson is the lead author of the Primary Fair Data Principles paper and lead author on the first paper describing a complete implementation of those principles over legacy data. He is a founding member of the FAIR Metrics Working Group, tasked with defining the precise, measurable behaviors that FAIR resources should exhibit. So I have now introduced for you, just to get you on track again, Joachim Ulrich and Mark Wilkinson. And the next person I shall be introducing will be Professor Dr. Barron Mons. He will be with us. He will not be with us joining the discussions because he had a conflict with other arrangements, but he will be speaking on a pre-recorded video. Professor Dr. Barron Mons is a molecular biologist and a leading FAIR data specialist. Since 2012, he's professor in biosemantics in the Leiden University Medical Center in the Netherlands. He is known for the FAIR Data Initiative and Go FAIR. Since 2017, he is heading the International Support and Coordination Office of the Go FAIR initiative. He is also the elected president of CODATA, the Standing Committee on Research Data Related Issues of the International Science Council. Now, the person who will be answering questions related to Professor Dr. Barron Mons' pre-recorded speech will be Eric Schultes, and he will be joining live during the discussion session. Dr. Schultes is the International Science Coordinator at the Go FAIR International Support and Coordination Office. He is also a member of the Leiden Center for Data Science. In recent years, Eric has been working with a diverse community of stakeholders to develop fair data and services within and outside the life sciences. Of course, in all these, when we're talking about digitalization, we have to have someone who's used to managing data. And on a on an internet basis. And for that, we'll be having Kylie Rodier with us. Kylie Rodier is currently the Digital Publishing Manager at the ISO Central Secretariat. Her focus is in XML-based publishing, and her previous roles involved XML-based work at John Wiley & Sons and Bloomsbury Publishing. The next speaker will be Professor Dr. Roman Schwartz, whom I've had the pleasure of knowing since 1987, I believe. Dr. Schwartz has a degree in physics and has been an acknowledged expert in the field of metrology and legal metrology for many decades. He was the vice president of PTB during the period of 2014 to 2020. And even though he is retired, he still works for PTB and OIML, and he's the president of OIML since 2017. And finally, we will have Etty Feller, representing the accreditation community. Her professional background is biochemistry and business administration with a major in management. She joined the Israel Laboratory Accreditation Authority in 2000, where she was nominated CEO in 2011. She has over 20 years of experience in the field of accreditation and assessment. And since 2019, she is the chair of ILAC. Due to technical reasons, Ms. Feller has only limited access to the workshop. If she is available live and if she can answer questions, that will be seen when we go on to the live discussion session. So now, please, Philip, can we start showing the pre-recorded videos? And sorry for the misunderstanding earlier.
Dear participants of the workshop, good morning, good evening, good afternoon, wherever you are on our planet. A warm welcome from me as well to this worldwide event on the international system of units in fair digital data. So what is a challenge? Why do we do that? What is a metrology actually of the future? Now, by 2050, it's estimated that about 50% to 80% of the population of the world lives in cities. What will these cities look like? How will the supply work? What measurements and metrology will be needed? And what quality infrastructure will be needed at the end? How can we guarantee high quality and reliability in complex interlinked systems? Now here we have a vision by Siemens actually on the metrology for the city of the future. We will have electricity. This will be powered by photovoltaics and wind energy. We need smart grids. We need charging poles and batteries for smart mobility. We certainly will have water, green gas, cooling, heating for smart buildings, smart factories. We will have 5G. And obviously, there's thousands of sensors and measurement technologies interconnected. So metrology is really essential. Everything is interconnected by 5G, by 6G. Digitalization is important. And the basis for everything are measurement data. And these measurement data are usually expressed in units of the SI. And the SI itself now is established by the Meter Convention, which was signed in 1875. By today, we have 102 member associated states and economies. They form together about 98% of the world's GDP. And this is the basis for the quality infrastructure. An example, worldwide, we have about 65,000 laboratories that are accredited along ISO IEC 17025, requesting traceability to the SI. So in this quality infrastructure, we have traceability, we have metrology, we have standards, we need standardization, we need accreditation, and all of that, what belongs to quality infrastructure, is laid down by the International Network on Quality Infrastructure, INETQI. And here you see the members of this INETQI in pink on the very top of the transparency, and most of these members are actually on the workshop. Now, this definition is a little bit lengthy, so let me summarize it. So quality infrastructure relies on metrology, which is represented on the international scale by legal metrology, OEML, or by the meter convention. Then we have standardization, which is actually ISO, IEC, and ITU. We need accreditation, which is IAF and ILAC. And in addition, we need conformity assessment and market surveillance in regulated areas. All of that now is mirrored actually on the national level. We have a national metrology institute, a national standards and accreditation bodies. We have certification inspection bodies below that, with testing laboratories and calibration laboratories, and all of that goes into enterprises and finally then to the customer. And obviously behind that are very complex processes. And all of these processes should be fully digitalized in the future. Now for that, we need definitely a metadata format for all measurement data. And the best would be that that would be a worldwide agreed measurement format, which is based on the SI. And this would not only be important for quality infrastructure, actually, would also be very, very important for industry, for health and global science. Now, the National Metrology Institutes and the BIPM actually, and the CIPM are closely related to science, to the Committee on Data of the International Science Council, CODATA. Here we are closely connected also to the European Open Science Cloud. And this is due to the fact because metrology is actually the science of measurement and applications, and our revised SI, the kilogram, the meter, and the second, is actually based, if you look in this inner circle, on defining constants, and these defining constants are established by CODATA in collaboration with the CIPM. So science, international science, is extremely important. Now, the vision could be, our grand vision, our joint grand vision could be to transform the SI in a digital framework so that we have a metadata format that is worldwide agreed for all measurement data based on the SI, for quality infrastructure worldwide, for industry and health, and for science. In order to initiate such a project, we have started at the CIPM and the BIPM in 2019 a project in the meter convention by defining it as the International System of Units, ESI, in the digital world. We have established a task group and an expert group, and the mission of the CIPM task group is to work towards a worldwide agreed, uniform, unambiguous, authoritative, and dependable data exchange format based on the International System of Units, the SI. We are tasked to coordinate this effort with all the stakeholders. And this is actually why you are here. So very much welcome to this workshop and join this effort. We would like to work together with all of you. And finally, the last task is to make the SI brochure machine readable, but this is just an internal task. Now, what kind of requirements for digital data would we have? So we have to make metrological data ready for the emerging challenges of digitalization in industry and research, facilitating reproducible data science and artificial intelligence. We need a profound transition for metrological applications in a digital world, since the machine actionable SI is fundamental in the digital knowledge domain. We need machine readable digital certificates for calibration, for instance. We need digital twins of measuring devices and equipment. And we need to overcome existing limitations in digital data usage due to diversity of formats and approaches. So the SI units and metrological concepts actually, for instance, uncertainty, may serve as a very important anchor point for reliable and secure data with a low risk of misinterpretation of the meaning. So our suggestion is, and this is endorsed by the CIPM, to have a layered structure. At the very lowest level, we have the SI core, which is simply the value of a quantity, the unit, the kind of quantity, the uncertainty, all of that which is usually in written form laid down in the SI brochure, in the VIM and the GAM. Then we need a service layer and application layer, and these are community dependent. For our community, we have various data and services and tools. For instance, we need a metrological thesaurus, we need ontologies, we need to make our databases, the key comparison databases, the CMCs, for instance, all of them machine readable, and we need the defining constants in a machine readable form. And all of that should be aligned with the FAIR principles for sure. And this layering concept actually based on a core SI representation and metrological traceability will then ensure reliability of all further applications. So this is our grand vision, and this grand vision needs to be a joint initiative. This is why we are here with you together. You see all the participants of the workshop. We have representatives of legal and industrial metrology, of international QI organizations, international unions, and the global science. And we would like to work together with you to guarantee exchange and interoperability of data in a global quality infrastructure. We hope to promote collaboration and shared goals. We need to identify priorities for the SI in the digital framework, metadata standards, services and tools. And it would be very important to support the whole enterprise by use cases to identify requirements and stepping stones. Now here is the workshop overview. So we start today with setting the scene with high-level views from science, standardization and metrology. Then we have 2 days of presentations, which give us insight into quality infrastructure and global science activities, as well as into regional metrology organizations, as well as into industry and unit representation activities. On Thursday, we have a breakout session where we discuss key aspects of the digital SI framework, which are the SI core representation, fair data, digital calibration certificates, and data ready for AI and ML. And finally, on Friday, we will have a plenary session again, where we come together and where we have a summary of the workshop and an open discussion on the joint needs and next steps. Now, one of the next steps could be that we agree that we intend to work together. And we have, in preparation of the workshop, we have started to write down how such an intention could look like. So let me just read that. So given that the International System of Units, the SI, underpins all measurements in industry, trade, legal metrology, and science, given that its transformation into a fully digital representation is necessary to facilitate efficient processes with industry, the quality infrastructure and its organization in modern research and development globally, given that such a digital representation relies upon robust, unambiguous and machine actionable digital representations of units of measurement, the breadth of potential applications is extensive and likely to grow, and progress on a global challenge requires participation and critical thinking from diverse communities. So at the end of the day, we hope that all of you could give a statement of intent that you would support such an activity, such a joint activity. So the following representatives of organizations have already indicated their cooperation and collaboration with the CIPM in pursuit of the digital SI framework and its propagation in compliance with FAIR principles. So we have shared this view already with OEML and CoData, and they provided the intention that they would support such a joint vision. Finally, the CIPM is very, very much interested to invite all organizations, every single organization which is now present on this workshop, all of you helping to shape and to join this effort. So this is not the end of a road, it's the beginning of a very, very long road. And you are all invited to come to a joint vision for the future. Now I'm at the end of my presentation. I would like to thank very much the members of the task and the expert group, which was spread all around the world. As you can see here, all these blue indicated areas. So in the task group, we had Hector Leitz, we had Ismail Castellaso, James Althoff, Alan Steele, Martin Sené, Fyodor Buligin, Pavel Nemeshyakov, Martin Milton, Yuning, Duan, and Wine and Low. And very importantly, we were supported by an expert group. And they actually did all the work over more than a year. They had weekly conferences. And there is a big thanks to all of them. Diego Coppa, Francisco Flamenco, Stuart Chark, Bob Hanisch, Ryan White, Alistair Forbes, Kazumoto Hosaka, and John Seon Park, as well as Blair Hall. And finally, a special thanks goes to Daniel Hutschenreuter, who was and is the chair of this expert group and did actually an excellent job. And in order that the technology, the technique really works, we need a strong support, and we have strong support by the BIPM in Paris. And this is Romain Coulon, it's Joanne Flamand, and Céline Felac. So thank you to all of you. And I hope that this workshop is a success, a big success. I hope that we can all agree and share this joint vision for the future. And I hope, really hope, that we can go the next steps together in order to come to fair digital data based on the SI. Thank you very much for your attention.
Good morning, and thank you to the conference organizers for inviting me to present. I've been asked to give a brief history of FAIR. I don't think that's possible without making the entire story about this man who is our next speaker. This is Dr. Barron Mons, and I'm going to tell you the history of FAIR from the perspective of someone who's been orbiting around Barron for about the last 18 years. Barron and I met first at the 2003 Oriel eBioSci meeting in Verena called Dealing with the Data Deluge. And at the time, Barron was working on projects around indexing concepts in biomedical text and web pages to improve search and query. And I was working on indexing structures of biomedical data types to improve interoperability and matchmaking. And these two projects were very complementary. And we realized that we had a very similar vision for where the world needed to go for true interoperability. It's worth noting that it was the following year that the W3C made a recommendation of the standards of RDF and OWL, and from that point on, the semantic web became a little bit more commodity. The tooling was a bit more off the shelf, easier to use, and the energy and enthusiasm around these ideas and strategies and technologies began to grow. So FAIR was sort of born at exactly the right moment. Now, my next major intersection with Barron was in May 2009, when he invited me to become a magnet group member of his new initiative called the Concept Web Alliance. His objective was to remove the redundancy and ambiguity from available knowledge in order to help deal with information overload, to semantically connect concepts, and to maximize the potential for knowledge discovery and reuse. What it was a mass collaborative approach to capture everything that exists as a formally registered concept so that these concepts could be shared and reused unambiguously. We worked on that for a while, and my next, again, major intersection with Barron was in January 2014 when he invited me to an unconference that he was hosting called Jointly Designing a Data Fairport. Now, I want to explain Barron's Fairport analogy and note that at this point in history, the acronym FAIR didn't exist. When Barron said Fairport, he meant fair as in just, not fair as in the acronym FAIR. So the idea was that people are data, and planes are data users, be they human or machine. Planes are able to collect the correct people from the correct place with very, very few errors. Passport control ensures that people only go to the places they're allowed to go, and this happens transparently to the airlines, by the way. And so any airline can pick up any authorized person from any airport and take them to any other airport completely frictionlessly. So if we can do this on a global scale for people, why can't we do it with data? And so at this unconference, there were about 31 attendees representing research infrastructures, policy institutes, publishers, semantic web specialists, innovators, computer scientists, and experimental, primarily e-scientists. And the discussion revolved around the context and the user needs and the technological challenges, access and business models, funding requirements, and governance of a global initiative around improving data reusability. All participants agreed that a global infrastructure for professional data publishing, discovery, exchange, and reuse was essential. I've highlighted some words there because they're important. Governance, global, and professional. At the outset, Barron had in mind that this was not going to be an academic project, that FAIR was going to be an international, well-governed, professional product, not based on professorware, as he calls it, software built by students, but rather it was going to be a reliable, stable international initiative. What came out of that meeting was a set of 23 sort of wish list items of what was going to be necessary to make data truly interoperable and truly reusable. You don't have to read that, but you'll see that it was still very very embryonic in a lot of people's minds what was needed. So that this list has sort of half ideas, unfinished ideas, overlapping ideas. Barron took this and sort of mulled over it for a while, and consequently found the acronym FAIR, which broke those requirements into the categories of findability, accessibility, interoperability, and reusability. Once they were put into those categories, we polished them up a bit and put them onto the Force 11 website for public comment. Chose Force 11 because they have access already to the community that we thought would be the best stakeholder community to give us feedback. In parallel with that, at the Biohackathon in 2015 in Nagasaki, Michel de Montier and I put together a working group of hackers who went through the FAIR principles again, and we polished them and we reworded them, and we made sure that they were each distinct from one another, addressing a singularly specific topic in each principle, and that they were completely unambiguous, at least as much as you could be without specifying technologies. And that became the final set of principles that was published in 2016 in Scientific Data. And I think in an act that Barron will regret for the rest of his life, he allowed me to be the lead author on that. And I thank you very much for that, Barron. It has been a career changer for me. So, what is FAIR? The findability principles refer to unambiguous identifiers supported by searchable metadata. The accessibility principles refer to clearly defined access protocols, preferably machine actionable. Interoperability refers to the use of shared vocabularies and ontologies, and again, preferably in a machine accessible format. And finally, the reusability principles are talking about contexts, allowing you to interpret data properly, and answering the question, do I want to use this data, not can I use this data? And finally, if I decide that I want to use the data, it will give me rich provenance so that I can cite accurately. From the point of publication, things happen very, very quickly. Same year, the EOSC invited an expert panel to give their guidance and opinions on how to build the EOSC. And one of the comments in that article is to make adequate data stewardship mandatory for all research proposals. Horizon 2020 funding should only support projects that properly address data stewardship, and those that do not specify FAIR should not be eligible for funding. That's an extremely strong statement. And the EU took it, the EC took it very seriously. You'll see that again in the same year, the Horizon 2020 guidelines on fair data management in their projects put FAIR at the center of their infographic on open data and data management plans. So the EC took it very seriously, but so did a lot of other people. Around the world, FAIR initiatives were cropping up, NIH, also in Canada, also in Africa, and many other places. So again, the objective of this being a global initiative is already being achieved the year that the principles came out. And you can see this again in a shout out from the G20 in 2016 at their summit, where they say we support appropriate efforts to provide open science and facilitate appropriate access to publicly funded research results based on the FAIR principles. The following year, France, Germany, and Netherlands established GoFair and the International Fair Support and Coordination Offices. And again, this is speaking to Barron's vision that this has to be professional and well governed. And zooming forward to just last week, February 14th, Valentine's Day 2021, the FAIR Principles paper reached 3,900 citations. Now, because this is a meeting on SI units, I'm going to spend a little bit of time talking about my own research in FAIR and how we address the problems of SI units in the research we've been doing with FAIR data. So my research has been for many years automated discovery and integration of data on the web and automatically matching it with appropriate tools. I have a collaboration, I've mentioned this fellow before, Michel Doncier, who's at Maastricht, founder of Semantic Science Integrated Ontology. I'm a co-author of SIO. And SIO, I just show you a tiny piece of the ontology on the right, is an example of a measurement record in SIO. So you have a node which represents a measurement value, and it has a value which is some literal, a string or a number, and it has a unit which is typed by a unit ontology term. So for example, systolic blood pressure is a type of measurement which has a value of, for example, 122, and has a unit which is of type millimeters of mercury. It's important to note that there's only one way to represent a measurement in SIO. So every measurement that you record is always in this structure, and that makes it very predictable for machines to work with. So way back in 2012, now this is pre-FAIR, but we've been revolving around these ideas and these concepts for a long time before the FAIR principles were written. My student and I wrote this paper where we were integrating data sets from around the world and trying to do this automatically. And what we found was, of course, there were unit conflicts from different measuring devices, different habits of different laboratories. So we could detect when this had occurred. And what we were able to do, because of these unit ontologies, was create a fully automated service that would then recalculate all of the measurement values and put them into whatever unit you wished. This was achieved using the semantics encoded in the measurement unit ontology. So because of those semantics, we could detect when it happened, and we knew exactly how to respond to it. And this was true for any kind of data set and any kind of measurement, whether it was pressure or length or whatever, right? And again, this is because there's only one way to do it. The unit was always recorded in exactly the same spot and in exactly the same way and grounded in the same ontology. Zoom forward to today, and I'm involved in the European Joint Program on Rare Diseases, which is a 100 million euro project to make the data in all European rare disease registries and biobanks fair. And this project is using exactly the same SIO model for capturing SI units in a fair manner. So this model has survived extremely well over 10 years, and that's because it works. So that is my history of FAIR, which is a perspective from my orbits around Barron as he converged on these now widely adopted and widely accepted concepts and principles. And so now, as I understand it, he's the next speaker. So we will hear from the man himself. I thank you again, the organizers, for inviting me. And take it away, Barron. Bye, everyone.
Hello, this is Bayern Munson, and I would like to talk for the next 15 minutes on FAIR in times of crisis and how we used the FAIR guiding principles to construct data on the COVID epidemic. Let me first briefly say something about FAIR itself, but I know that Mark Wilkinson will talk much more about it. He's the first author of the article. But one of the things we always say now is that we are approaching 4,000 citations, but most people that cite the article haven't even read it, because the FAIR principles, as you can see them here, are really meant in its core to enable research with the help of machines. And therefore, I now summarize FAIR as the machine knows what I mean. The virus outbreak data network is one of the ways in which we have applied the FAIR principles. It was immediately endorsed by CODATA, CoFair, the Research Data Alliance, and the World Data System. And one of the key things that we see here is that in COVID, with all the political issues, there is no way that the data, for example, would go ever from China to the United States or the other way around. and we therefore have to visit them locally. So the other thing I always say now is that we stop data sharing, we start data visiting, and we establish a difference between established knowledge. It's here indicated by the orange squares, like in EBI, or in the Netherlands, or in Norway, the Human Protein Atlas in Sweden, and the NCBI in the United States. The data could be anywhere, and they are usually not sensitive because they are already published. Then you have the data that are personal data, and we have to visit them because they are too sensitive to share. That's done by a system which I have no time to go into. It's called the Personal Health Train. We also have it for agriculture already, where it is called the Farm Data Train, and it visits stations that contain FAIR metadata and tell them where the data are and whether they can access them and under which conditions. This is all based on the so-called FAIR digital object, where everything, starting with the smallest possible digital record that means anything like a single identifier, and even that should already have some sort of metadata saying that from which ontology is this identifier. And each digital object should have a globally unique, persistent, and resolvable identifier, which is also true in the scope of this meeting for units of measure. So the metadata should tell the system, the virtual machine, for example, whether any measurements that come out in the FAIR digital record, which could be a whole big data file, are centimeters or inches or Fahrenheit or Celsius, etc. That can be described in the metadata in machine readable format, and each of the units of measure should in itself have a globally unique, persistent, and resolvable identifier, so the machine knows what we mean by inches or centimeters, no matter how we might write it in human readable language. In the life sciences, we also deal with the GDPR issue of very sensitive data. So we have all kinds of data capture, personal data. And what we are now building is that the decisions on how these data can be reused, the R in FAIR, are in fact decided by the citizen. So the citizen decides where the actual personal data are stored, polymorphically encrypted in a vault, for example. Then there is the FAIR metadata in a FAIR data point that is separated but points to the data in a permalink. That's where the data are. And here you describe under which conditions the data can be reused, for example, with a consent instruction. And then you can go and do all kinds of research on these data in a distributed fashion by virtual machines. That is one of the main things that you can do with FAIR. Of course, you have to explain that to people that have their smartwatches, their record forms in the hospital, high throughput testing as we do now for COVID and vaccination. And we have to explain that in a very simple way. In the Netherlands, we call it Jip en Janneke. This is a very famous story of children's books, how this works and what levels of consent, 1, 2, 3, 4, can be given. And that has to be done in apps and the forms for doctors and everything, so that both virtual machines and humans can find, access, interoperate, and reuse, therefore, the data in these FAIR data stations. Now, of course, the data themselves could have such a high level of security that they cannot even be accessed. Even that can be described in the FAIR data point, in the FAIR metadata. Hopefully, more and more data will actually be FAIR and reusable by machines straight away, and therefore also by people. The metadata could also say, by the way, the data are not yet FAIR. So if you want to use them, they are findable and accessible, not interoperable and reusable. You need to verify them, maybe make a new distribution of the data with different metadata and say we have now a machine readable version of the same data. And maybe Mark can answer some questions about that later as well. Then you can say no, for your type of question, for example, commercial use, you cannot use the data. You have to ask special permission. Sometimes the data do not have to be FAIR. They could simply be CT scans in DICOM format, and as long as that is expressed in the metadata and the machine learning algorithm says, okay, I can deal with DICOM pictures, it can go in. of course, there will also be fair data points that say, no, I have no interesting data for you. And sometimes the data may be archived. I gave this presentation to CERN, and they need to then upload tapes from maybe years ago into a fair reusability environment so that machines can actually use them. And then you have to wait for that. That's all fine. This is also to show that fair is in no way the same as open. Now, how have we used that for COVID? I cannot go into any detail here, but just to flash it to you, we have used text mining from papers, real-world observations from patients. We have a hypothesis for the disease model based on the interaction of the virus with the human proteome. Far too complicated to go into, but we create a disease model in which we can rationalize, for example, drugs. And we also have experimental validation in organ-on-a-chip, organoid type things, real lung tissue where we can pass the serum of patients. But we are now concentrating on the virtual part of it, the rationalization in a fair environment. So here's a machine-readable model. The orange balls are the genes that we have decided we think are involved in the vasculitis, in the hyperemia, the disease progression until you die in the lung and in the heart and everywhere. But it is characterized by extravasation, so vascular leakage, and thrombosis at the same time, which obviously even for non-health people means it's pretty dangerous, if not lethal. Now, if you take a drug that meanwhile has been shown to work for COVID, at least in certain patients, you see that everything we know, we call this the fair digital twin of the drug. That's all the assertions and triples that we know about dexamethasone. We, as it were, throw the drug in a virtual petri dish where we have a conceptual model about the SARS-CoV-2 virus and how it influences different genes, leading to this problem of fatal organ failure. And the system tells us, forget about the statistical details, that chances are very high that dexamethasone, which inhibits prostaglandin E and its precursors, would actually preclude the vascular leakage specifically, but also thrombolytic events later on in the patient. And we can do with the same model, we can basically throw all the drugs in Wikipedia that are already tested for COVID in there. And here you see, for example, hydroxychloroquine, which appears to have hardly any connection to the data model. And by now, I think everybody agreed we should forget about hydroxychloroquine as a serious treatment. Now, this is all far too complex to do by hand. So we need to do this in a graph. And if you just look at dexamethasone alone, that it inhibits prostaglandin E, which is also called dinoprostone, which gives you another indication. You cannot use names, but you need unique identifiers. These are the common genes between the two, and each of these genes may have 20,000 papers, so there is no way you can read about this, but the machine will tell you, in this case with the commercial partner Eurytos, what is the evidence that dexamethasone inhibits dinoprostone and how dinoprostone is involved in the disease progression of COVID, and therefore if you inhibit it, you can prevent disease progression. This is not a dream. This is all working with TNO and the Dutch AI coalition. You can do several iterations going to distributed models, and we have shown that this can be done over fair data points in Africa, and you can send around Sparkle queries as long as there is fair metadata and fair data around. So with that, I thank you very much, and this would be open for questions at any time. Thank you.
Hello, my name is Kylie Rodier, and I'm the Digital Publishing Manager at ISO Central Secretariat. Today, I'm going to give a brief overview of digitalization at ISO. This presentation will briefly go over the history of ISO and its publication formats, the current initiatives and the topic of machine readability within the standards industry, and the next steps for the near future. ISO, as you well know, was founded in 1947, created to publish standards in a complementary activity to the then newly created World Trade Organization. In the 1980s, with the advent of computers and the internet, email and digital-based practices started changing the way people work around the world. This continued into the 1990s with the invention of PDF and XML, the successor to HTML. These are two markup languages that describe documents. In the 2000s, PDFs were integrated into the ISO toolchain. The 2000s marked a period of great change across publishing in general. Many publishers started integrating digital formats and work processes into their business practice. In 2008, ISO CS was mandated to provide XML versions of standards to its members. And in 2019, with the very real understanding of machine readability kind of echoing around the standards industry, the ISO TMB, the Technical Management Board, created the Strategic Advisory Group on Machine Readable Standards. For those who aren't familiar with XML, this is a very, very brief primer. XML stands for Extensible Markup Language and is a tagging language that describes a document. It is very document-centric in nature. It comes in different types or schema. We currently use NISO STS in collaboration with IEC CEN and members. The plus point of XML in a publishing context is that it can be transformed into multiple other formats, and it can be enriched with metadata. Other formats that ISO CS currently publishes is HTML. A good example is the STEP module resource library, ISO 10303, and XML and spreadsheets, as well as the PDF version of the country code standard, ISO 3166. Currently under consideration is the report released by the Strategic Advisory Group on Machine Readable Standards. This report identified real user and market need for data-centric standards. This was particularly relevant for technical industries such as energy, construction, engineering, aerospace, etc., and affects standards development processes right from drafting through to distribution. The group coined a new product name, ISO Smart, standard that is machine applicable, readable, and transferable. And the group also identified that many technical committees were already working on products, methodologies, and data sets that could be seen as machine readable. There is a very real understanding that the world is moving towards a more digital-centric way of working, and publishing is no different. Standards development, distribution, and use is being affected by the way people work every single day. And we must recognize, of course, that certain industries are more data-centric now than others, and that we must offer other formats beyond PDF and beyond a document-centric format, if you like, in order to address that need. And so this puts machine readability within ISO's immediate focus. When considering machine readability, there are multiple definitions. Some are very industry specific. You could also say machine interpretability, machine interoperability. Well, what we think about when we describe a machine readable standard, for example, is this connection between data and machine. Now, normally humans have an interpretation role in taking data and ensuring that a machine can understand and act on that data. The idea behind a machine readable standard is that this human role wouldn't necessarily be needed. There would be a direct connection between the data, the standard, and the machine needing to use it and implement it within an industry context. However, that doesn't necessarily mean that a machine readable standard is not human readable. That can very much be the case. There are great arguments for saying that very enriched XML satisfies the machine readable or interoperable requirements needed in certain industries. That being said, when considering how to implement a machine readable standard, there are multiple stakeholders and issues to take into account, including formats and infrastructure, distribution, commercial viability, and so on. And when making decisions around those considerations, what must be used is real life user and industry practice. And we can gain this from the multiple organizations and groups already working on the topic and developing machine readable products, as well as listening to our experts. I wanted to share with you this image. This and various images like it are kind of making the rounds, so to speak, among standards development organizations, and just describes a way to classify standards in terms of their granularity and their quote machine readability. You will see a kind of evolution, though I must be very clear when saying that when considering a future in which we have machine readable standards, they would exist alongside PDF, as PDF is still the most consumed document format that's used across the world. The other major initiative I wanted to bring to your attention today is the Osd Program, or the Online Standards Development Program. This is an XML-based tool to draft standards. We are working on this using a software called Fonto, and we are working on this in collaboration with IEC. This will be offered to ISO and IEC technical committees to draft standards in a structured yet collaborative way. So what happens next? The report created and issued by the Strategic Advisory Group on Machine Readable Standards has been considered by the ISO Technical Management Board. They looked at it last year. And ISO Council, the highest governance body within the ISO system, is considering the report this month. At the time of making this presentation, there aren't any outcomes to report on yet. But should Council approve the recommendations made in the report, there is an internal project team and pilot projects kind of poised to start work on the topic. And of course, the OSD program is ongoing and has various pilot projects in action already. In conclusion, standards publishing must evolve with a more data-driven and digitized world. We have initiatives already in action, but need to take a more comprehensive and holistic approach to the whole development process, from drafting through to editing and building consensus through to distribution and use in industry. We are working in collaboration with other international partners on this in order to move forward together in a cohesive way across the industry. Most vital, though, is getting information and input from technical committees and from industry. It's this information that we need in order to make good decisions around what machine readable standards look like and how we can get them to where they're needed most. I hope this presentation was helpful in giving an overview, and I thank you for your attention.
Good morning, good afternoon, depending on the time zone you're in. I'm Roman Schwartz, President of the CML, the International Committee of Legal Metrology. I'm very pleased and grateful for the invitation to contribute to this exciting CIPM workshop, which is dealing with digitalization in general and the SI in fair digital data in particular. Let me begin by wishing you all the best and success in these challenging times. My presentation is about digitalization in metrology, the view of the OML. Let me begin with a brief introduction of the OML, the International Organization of Legal Metrology. The OML is an intergovernmental treaty organization established in 1955 with currently 61 member states and 65 corresponding member countries and economies, thus a total of 126 members. The major fields of activity of the OML are: firstly, the technical work. This is done in about 50 active project groups related to 18 technical committees and 45 subcommittees. The technical work aims at the global harmonization of metrological requirements and test procedures for measuring instruments under legal control. A good example is the OML recommendation number 76 for non-automatic weighing instruments, which has been taken over into the national regulations of most OML member states. The second major activity is the Oml Certification System, abbreviated OML CS. This includes now 38 measuring instrument categories, where respective certificates of conformity are issued by 12 issuing authorities, which can be considered as certification bodies. In addition, there are 32 so-called utilizers who do not have their own test facilities, hence do not issue certificates, but have declared to accept certificates and test data from issuing authorities which participate in the OML CS. The third important field of activity is the support of countries and economies with emerging metrology systems, abbreviated SEAMS. And finally, of course, the OML does a lot of international cooperation with many organizations and liaison. With this slide, I would like to explain who the major stakeholders in legal metrology are. Let me begin with the manufacturers of measuring instruments, followed by the test laboratories and certification bodies, and the field inspection and supervising bodies. Also the customers and users of the measuring instruments. And last but not least, we have the regulatory bodies, which are responsible for an appropriate, well-functioning legal framework, which ensures trust and confidence in official and commercial measurements. This slide shows how metrological activities are always related with other quality infrastructure activities, with the consequence that the digital transformation of metrology requires a holistic approach of all parties involved in the quality infrastructure of a country or economy. The three major pillars of the quality infrastructure are metrology, standardization, and accreditation, with 6 international organizations having responsibility for the worldwide harmonization: the BIPM and the OML for metrology, ISO and IEC for standardization, and ILAC and IRF for accreditation. Below the metrology institutes and the standardization and accreditation bodies, there are laboratories and bodies being responsible for calibration, testing, certification, and inspection. In addition, according to the definition of INET-QI, the International Network on Quality Infrastructure, QI activities also include conformity assessment and market surveillance. The yellow arrows show the quality infrastructure activities in which the OML is primarily involved. Since about 25 years, the Internet has changed the world significantly, also the world of measuring instruments, which is more and more becoming part of the Internet of Things. This has significant consequences and offers a lot of opportunities and new business areas, which I would like to explain with this slide. It shows the life cycle of a smart network device using the example of an industrial scale. The life cycle begins with the production in a smart factory, where the smart product keeps in touch with the manufacturer through the internet. This offers the chance for the manufacturer to remotely control the units and to offer customized services such as maintenance, customers' goods management, etc., so-called smart services. Therefore, the Internet of Things is complemented by the Internet of Services. The smart industrial scale continuously generates data, for example, about its performance, which are communicated and stored in a secure cloud and can be analyzed, often in real time, by the manufacturer and other stakeholders involved. Real-time analysis and compression of these data lead to so-called smart data, which can be used for re-evaluation, further improvements, new business areas, optimized products and processes, for instance, predictive maintenance. All this is possible because smart network devices keep in touch with the manufacturer and other stakeholders throughout their life cycle. I would like to summarize the consequences and opportunities for networked instruments as follows. Smart networked instruments continuously communicate. That means they send and exchange data, where these data are continuously stored, analyzed, and correlated in real time. Centralized and decentralized data processing act together and have self-learning and self-checking systems. This allows predictive or even remote maintenance and remote surveillance. All this forms part of a digital transformation process where humans will have to learn how to interact with intelligent systems having learning and assistance systems. One of the consequences of this development is that the quality infrastructure must become smart too. What does this mean? We need digital and automated processes based on machine-readable data. We need digital machine-readable documents and certificates based on standardized representations of metrological data and units. We need digital machine-readable standards. We need an interoperability of processes and quality infrastructure activities based on standardized terminology, controlled vocabulary, and ontologies. In simple words, we need one language for both the networked instruments and the respective quality infrastructure processes. We also need remote assessment and self-assessment methods based on the Internet of Things functionality for measuring instruments. Finally, and very important for legal metrology, we need appropriate technology, for example blockchain, to provide secure access and use of sensitive data. This leads me to my first thesis. The digital transformation of scientific, industrial, and legal metrology activities should be a holistic process which includes all relevant aspects and activities from the beginning. Calibration and recalibration, testing and retesting, certification and recertification, verification and re-verification or inspection, market surveillance, accreditation, and also standardization. This requires good cooperation of all stakeholders. That means manufacturers and manufacturers associations, national and regional regulatory and supervising bodies, international organizations in the field of quality infrastructure, notably the BIPM, the OML, ISO IEC, ILAC IRF, and maybe others. A challenge, especially for legal metrology, is the digital transformation of the various processes during the life cycle of a product. I will go into this in more detail in my presentation tomorrow, but would like to have a brief look at this already here. The life cycle of a product, the measuring instrument, begins with the manufacturer, who is responsible for the product design and the production line, where a third party takes care of the conformity assessment steps, comprising type examination and the surveillance of the quality system for the production. These two steps, accompanied by market surveillance activities, guarantee that the products which are placed on the market are in conformity to the approved and certified type. These activities are often designated as pre-market activities. Once the customer has bought the product and has put it into use, he will be responsible for the proper installation and use, and has to take care that the verification body performs the verification and the regular re-verification. These activities are often designated as post-market activities. In addition, the instrument usually also requires regular maintenance, eventually repair, and also software updates. For the sake of completeness, I would like to mention that in some countries and regions, market surveillance is also considered as a post-market activity. Looking at the various processes during the life cycle of a product, it becomes obvious that the digital transformation of these processes can only be successful and effective if it is based on the exchange of fair digital data, where the emphasis is on the I, that means the interoperability of data and processes. This leads me to my second thesis. Smart products will remain in touch with the manufacturer and other stakeholders throughout their life cycle, and they will be accompanied by so-called digital representations, where the relevant data should be fair, should be based on the SI, and should be complete. That means should include all relevant information that is necessary to perform any kind of metrological activity, in this case, legal metrology activity. The digital transformation of metrology should therefore fit into the natural life cycle of a product, which is the smart measuring instrument or measuring system, from its development, testing, production, and entering into the market, up to its regular calibration and recalibration, verification and re-verification, inspection, or market surveillance. With this, I want to conclude and summarize my presentation as follows. The OML supports the digital transformation of metrology as an important part of the quality infrastructure of countries and economies. The OML supports a holistic approach for the digital transformation of scientific, industrial, and legal metrology in close cooperation with all players in the field of the quality infrastructure. The OML supports a digital transformation of metrological processes and activities that fits to the natural life cycle of a smart measuring instrument and system. And data formats for digital twins should be fair, based on the SI, and complete. That means should include all relevant information that is necessary to perform any kind of metrological activity, be it calibration, conformity assessment, verification, inspection, market surveillance, or accreditation by the relevant bodies. With this, I thank you for your attention. If there are any questions, I'm certainly ready to take and answer them in the Q&A session. Thank you.
Good morning, good evening, good afternoon, everyone around the world. It's a great privilege for me to take part in this international conference. On behalf of ILAC, I'm Eti Feller, ILAC Chair, and I will give the presentation on behalf of ILAC, Accreditation and Dissemination of Metrological Traceability Data. I will begin with ILAC goal and role. The principle of International Forum for Recognition of Competence of Test, Calibration, Inspection Bodies, Proficiency Testing Provider, and Reference Material Producer worldwide through its Mutual Recognition Arrangement, our MRA. The second point is to develop an appropriate harmonized of laboratory inspections body PT and RMP accreditation practice to promote labs and inspection accreditation as a trade facilitation tool and to assist with development of accreditation system for all of those under our ILAC MRA. What is ILAC? For those of you that knows and for newcomers, the acronym is International Laboratory Accreditation Corporation. ILAC was established in 1977 to promote communication among labs accreditation bodies of the world. Formalized as a corporation in 1996 with 44 bodies, signatories to a mutual understanding, the MOU. On 2000, a mutual recognition arrangement, MRA, was signed among those members, and ILAC was incorporated in the Netherlands in 2003. ILAC MRA was extended 3 times. The first one in 2012 to include inspection body, in 2019 to include accreditation of proficiency testing providers, and in 2020 include the reference material producer. Right now we have 102 signatories, which mean full members to the arrangement, and they represent 104 economies. Almost 82,000 labs, 12,000 inspection body, 560 proficiency testing providers, and 40 reference material producers have been accredited by our 102 ILAC full members. And this is the ILAC MRA mark. And in the next couple of slides, I will explain the principles of using the ILAC MRA mark. ILAC MRA mark, right now we have 83 ILAC signatories, which mean they signed an agreement for the use of the ILAC MRA mark. These signatories are entitled to use the combined ILAC MRA mark for accreditation activities covered by the scope of their ILAC MRA signatory status. It's also an option for these ILAC MRA signatories. They are able to permit their accreditation conformity assessment body, the CABs, to use accreditation CAB combined with the ILAC MRA mark. And in this way, we promote the accreditation around the world. Recently, we update several documents that reflect the need of the market in metrological traceability. The first one is the latest version of ILAC P10, ILAC policy on metrology, traceability of measurement results, has been published and it's available on ILAC website. This document addressed the ILAC policy and on metrological traceability of measurement results. The latest version reflects the 2017 version of ISO IC 17025 and provide additional clarification of its applicability to other conformity assessment activity where measurement is involved. For your consideration, the implementation date for this most recent version of ILAC P10 is July 2021. The latest version of ILAC P14 was published on September 2020. ILAC policy for measurement uncertainty in calibration. This document set out the requirement and guidelines for evaluation of statement of uncertainty in calibration. and the latest version reflect the 2017 versions of ISO IC 17011 and ISO IC 17025. It's important to mention that the policy is based on the guideline of uncertainty in measurement, the GUM, and retain the common understanding of the terms of CMC for the joint declaration issued by the BIPM and ILAC. The implementation for this document is March 2021. ILAC BIPM joint statement is available for you via our website, and accreditation of calibration and measurement services of National Metrology Institute. In general, it facilitates the process for accreditation bodies when they accredit the measurement services of NMIs. ILAC publication, through the last couple of years, several documents were updated to reflect the needs of the market, of our signatories, and the CAPs that are accredited by our signatories. The list is, part of the list is shown here in this slide and in the next slide. And just to show you that although all of us around the world had to implement new ways of working, ILAC still update the document through this last year. ILAC P15 application of 17020 for accreditation of inspection bodies was also published last year, and several guidelines in order to clarify the needs of the market. Fact sheets are available in ILAC website. Specifying accreditation for COVID-19 testing was published also in August 2020. Many of the ILAC documents and brochure have been translated into a range of different languages. And if you think that you need in a language that is not published, please contact your local AB, and we will be happy to assist with any language. ILAC work with key international partners, and you can see the list here in this slide. The work with each one of them is different, either via MOU or joint steering committees, or working together through the assessment system, with each one to make sure that it reflects the needs of ILAC and the partner organization. All the international partnership and MOUs are published in our website, and you can find a short list here in this presentation, in this slide, sorry. International Network on Quality Infrastructure, the acronym is INET-QI. ILAC is part of INET-QI. International organization have agreed to enhance their cooperation in promoting the understanding, value, and acceptance of quality infrastructure, and provide guidelines and support to make it more effective to implement and integrate the quality system worldwide. This consortium was led by ILAC for the last 2 years, and ILAC was one of the original INET-QI partners. There are 2 websites that ILAC take part in that can provide a lot of information about the way that we work and influence the market. Public Sector Assurance website This website was initially a collective initiative between ILAC, ISO, IF, IC, and IIOC. Recently, we have several other organizations that join us, and this website includes case studies and researcher on the recognition of the ILAC MRA by governments and regulators. There are over 325 case studies, 88 research papers, and 57 supporting material available for your view and use. And always we will be happy to get more information and to update this website. The second website, Business Benefit website, again, is a website that the aim is to give the businesses around the world examples. There are over 95 case studies in 6 different areas that show the value of accreditation. There are also 74 research papers, and we are always welcoming everyone that want to add information and share their experience with us. Here you can find a short list for your consideration with a source of further information, and we will be happy to assist everyone with its needs. Thank you very much for listening, and I will be very happy to answer any question or any need for clarification. Thank you very much. Take care.
Okay, yes, please. No. Okay. Yes. I would like to thank all of our speakers. And I would like to give you a brief summary of the highlights, but before I do that, I would like to first and foremost congratulate the metrology community and all of its stakeholders for having succeeded in reinventing themselves to prepare for a leap into the future. And I think this shows that there is a lot to be done for the other institutions of the quality infrastructure to make that leap. During this plenary, we have heard a historical perspective of metrology. We have heard about the effect of Industrial Revolution 4.0 and digitalization, of course, on the quality infrastructure in general, and on metrology in particular, both scientific and legal metrology. We've heard about the development of the concept fair data and the relationship between the principles of the FAIR principles and the SI units. And we've listened to a very interesting discussion of how FAIR in times of crisis can contribute to problem solving. We've listened to the machine readability of standards and online standards development and smart networked devices for a better and more efficient legal metrology. And finally, we've listened to the dissemination of traceability and which tools that are available for that. Now, with this, I think I'd like to ask our moderator, Dr. Tanish, if he would like to add anything to my summary. And after that, we can, I think, open the question-answer session.
Very much, Mary. First, I want to thank you for your excellent leadership of this session and that nice synthesis. I will maybe say a little bit more later on, but let me at this point also appeal to participants that we are still in the expert group willing to accept use cases and pain points. If you would still send those in to me. There was a a plea for those on the conference website. We're still open to receiving those. So at this point, I think we can open up the discussion. And if you have questions or comments, please type them into the chat. There's one. Very good. I'm going to start with a question that came in for Roman Schwartz from Marina Romanchikova. And she asks, where do you see the responsibility of retesting of reinforcement learning systems where AI software decision-making is constantly updated following the input data stream? And this is a very relevant question as we talk further about AI and machine learning later on in the conference.
Well, I'm going to try an answer. It's a good question, not an easy question. I think it will be part of the discussion we will have to lead on the topic of digital transformation of metrology processes. I'm convinced that the digital transformation of metrology processes will change the world significantly, and also the legal metrology world. And when we have to think about reference infrastructures, reference architectures for systems under legal control, we will have to think of newly think about responsibilities. And I think this is part of what we have to discuss and find an answer when we have the discussions about the the digital transformation of legal metrology process in general. So it will be part of the decision who has the responsibility for the reinforcement learning systems. And this has not yet been decided, and I can't tell you the complete answer right now. It's part of the discussion. Thank you.
Very much a work in progress.
Yes.
I see a question from Sasha Eichstadt to all. I'll let whoever wants to take this one jump out. Where do you think is the interoperability between the quality bodies, the QI bodies, important in the near future? What does that mean for FAIR principles in the individual developments within the organizations? If I could paraphrase this, how is FAIR going to percolate throughout our metrology and quality infrastructure organizations? Anybody want to grab that one? Maybe Weinand or Joachim? Or Joachim?
Yes, maybe. Can you hear me? Yeah, maybe from my side, yes, it will be very, for instance, the long run for the certification of measurement devices. Important in digital certification certificates. It will be important for the verification for the customers. It will be important for getting the data from sensors to the customers, but also to the providers. So what we think is, and this is part of the Metrology Cloud, which was introduced also will be introduced, I think, tomorrow by Roman Schwartz, processes which we need to make quality infrastructure working have to be digitalized in a way that we can find each other. And all these processes are continuously available on a cloud, so that we can access all the data which the single party need and see it everything in a digital way.
Thank you. Here's one for you, Etty, from Fernando Kornblit. Is there an ILAC policy on fair data and or digital transformation?
Right now, there is no a document or a policy document for this need. First, we have to realize that the international standards gives the option for digitalization, the standard for AB, and the same, the 17025 and the other standards for accreditation. I think that at this point of time, the information is based on the need of the market and also on regulation, either government regulation or country regulation or economy regulation, and also via regions regulation. And accreditation have to make sure the competence of personnel to perform the accreditation and according to the scope of accreditation, but also to follow the regulation in their economy, country, or region. So at this point, we weren't asked even to have a policy document on behalf of ILAC for these needs. Thank you.
Thank you. Here's one I think I'll direct to Mark and to Eric from Emma Williams. I'm still quite new to these ideas, but I found the interoperable in FAIR means something slightly different to the interoperable in metrology. As a metrologist, I think the two data sets are interoperable when we understand the differences between them through, for example, comparisons and robust uncertainty analyses. I'm interested as we start talking to each other in these ways, how and whether we should link these ideas.
Eric, do you want to go first or should I?
Mark, you go first.
Okay. So I think the intended meaning of interoperability was that a machine would understand the purpose of both data sets and how they could be used and whether they are about the same thing, right? So if you were building an agent that did automated data integration, it would unambiguously know that these two data sets were in fact about the same thing. And so that's what we really meant by interoperability is the unambiguous communication of meaning. Eric, do you want to keep going?
Well, yeah, you know, it's metrology is certainly new to me as a discipline, so I'm very interested to learn more. And this distinction that's being made here between, you know, interoperability in metrology is looking for differences or, you know, comparable data sets where you can probably find measurable, meaningful differences. Versus, I think, Mark, the definition that you just gave, which is kind of a, you know, a seamless semantic fabric covering multiple components. So I agree. This is a very, you know, this could be potentially a very important area to focus on as we go forward to make sure that we align the FAIR principle meaning of interoperability with the probably by now well-established meaning of interoperability in metrology. Certainly, Mark, to the degree that we achieve interoperability at the semantic level, like you were mentioning, we would be able to parse out nuances in meaning and maybe the different perspective that's being built into components when they come together in a fair data machine actionable sense. So yeah, I think it's an excellent point for further discussion.
Thank you. I think this one's for Roman from Enrique Gaetan. What would be the responsibility of certification and accreditation bodies in relation to the adoption of new technologies, for example, certifications based on the blockchain?
Thank you. That's a very good question. This brings me to the point that we certainly need much more competence and know-how in the future with these bodies concerning IT questions and IT knowledge. I think it's really key that these regulatory bodies and accreditation bodies, certification bodies need the appropriate competence to judge new technologies. And I think we have to cooperate with bodies being competent in these fields, like we have in Germany the BSI, and we have certainly in other countries other competent bodies.
Thank you for that. Here's one near and dear to my heart from Mohammed Gadelrab. As IT and software are increasingly becoming critical components of metrology ecosystems, should not national metrology institutes have dedicated specialized departments and labs for metrological IT systems? I think this will significantly accelerate the metrology digitalization process. Well, I couldn't agree more. I wonder if some of my other NMI colleagues would endorse that as well.
Yeah, I think.
Wynand or Joachim?
Oh, thank you, Robert. This is a very good remark, Mohammed. Thank you. Well, I think as the BIPM is in any case now moving into this field more and more, and there will be more coordination from the CIPM and the consultative committees, I think the interest in this will also increase from the NMIs. Of course, the leading NMIs already have these type of people and departments. And at the moment, they are actually driving the process, the likes of the PTBs and the NISTs and so on. And it's definitely something that we would ask the NMIs to seriously look at. But of course, NMIs normally spend their money where they need to really ease in their part of the world. But we will, from the CIPM, ensure that there's good coordination going on and also good assistance from the BIPM. Thank you for that question, Mohammed.
For the NMIs. So for sure, you know, Bob, that NIST is extremely active in this field. I know that NIM in China is building up a complete department. We do that as well as at PDB as good as we can. So there was an advice from a external committee that we need a department of 100 people at least to deal with that. So presently, actually, to deal with that, we are proposing essentially a new institute with up to 400 people being involved to proceed in this direction. I see a huge task for NMIs coming up, and maybe also relating to one of the first questions, who is responsible finally also, who should be responsible for making sure that KI is taking the right decisions and getting the right data. I think for the data quality, the metrology community should be responsible for that, even though in Germany, for instance, this is not clarified in the moment on the legal issue, on the legal part. So we are trying to talk to politicians and to other stakeholders how we ensure that the quality of data, of test data for KI is correct. And then we, on the basis of that, we have also to ensure that the algorithms work correctly. And I think this is a task of the quality infrastructure together. And it's at least in our national context in the moment, it's not really clear who's at the end of the day responsible for that.
Well, I hope that my supervisors are listening to this conversation because we could use some more help in this area. Let's see. From Dorothea Knopf, who will care for the harmonization and acceptance of future and existing ontologies and semantics in the field of metrology? Will there be a coordination between different organizations to avoid ambiguous terminology for data in metrology? I will offer a first answer to that, which is that's sort of what our expert group is doing under the task group under the CIPM. But clearly this is going to require very broad collaboration amongst NMIs and organizations such as GoFair and CoData and the Research Data Alliance and so forth. If anybody else wants to contribute to that answer. Yes, Eric.
You mentioned Go Fair. Go ahead, Eric. This is your baby, not mine.
Yeah, sure. Well, just to mention, so I agree, Bob, and just to mention that tomorrow there's a presentation by myself on metadata for machine workshops that were spun out of Go Fair over the last couple of years, and in part, the motive behind these workshops is to start providing a kind of guidance for communities, however they may emerge and want to organize themselves in terms of framing their ontologies and vocabularies. So I'll give a pretty nice example, just very recent now, from the Dutch COVID research program, where 62 research projects have come together to build a vocabulary for their joint projects. And now they're in the process of setting up long-term data stewards who will maintain those vocabularies over time. And there's additional COVID programs popping up within the Netherlands and elsewhere that can now have these vocabularies available to them for reuse as well. So a very active concern in Go Fair.
Another sort of infrastructure component that Go Fair has built are a thing called implementation networks, and they're really designed to do exactly what this question is about, to get all of the stakeholders within a specific community into the same room or into the same chat, I guess, in these times, and make sure that they're coordinating with each other. The Go Fair office assists you in doing this coordination. They hold a yearly meeting where all of them come together. They look for cross-pollination between the networks. And so if this community is just getting started, a Go Fair implementation network might be a really good first step.
In fact, we did set one up a couple of years ago. Didn't quite get traction just yet, but I think after this workshop, we're likely to see that get energized. We're almost out of time. I have one interesting question here I'm going to pose before we close from Oman Ramos. Today we are talking about metrology and digital transformation, and also about the SI and FAIR. But what will metrology be like in 10 years? And how will this change affect an NMI? What should we do now as NMIs to be prepared? Who wants that one?
Wyman first, please.
I can give a go, or is that fine?
Yes. Yes. Yes.
Well, the CIPM at the moment is doing that strategy 2030 and beyond. And this is the question that we are looking at. My apologies. And really, what technologies, how is technology changing? What are the disrupting technologies for the metrology world? And digitalization is basically one of them. And then, of course, things like remote or embedded calibration. All these things are really going to change the way that the NMIs and the BIPM, the CIPM is working. And yes, I think my final reply to that is in about 2 months from now, the new draft strategy of the CIPM will be out for comment. And Oman, I really hope that we can answer some of these questions for you. But of course, we are always looking for input from the community to assist us in basically defining these plans and strategies for the future. Thank you.
Maybe from my side, a short comment on that, which is also entering probably into the strategy document of the CIPM. In my opinion, we will face a tremendous change from the understanding of a single sensor and a measuring device to the understanding of systems of huge numbers of sensors with different quantities, which we have to understand to finally and to characterize metrologically to make finally good KI decisions. So if you think on autonomous driving car, there are 400 different sensors, and finally you have to decide to go faster, to stop, to brake, or to go left or right. and the metrology behind that, the characterization, the traceability of individual quantities, in my opinion, in the moment is not clear. And we have no good concepts on that. We have to develop that and bring it into legislation, into standardization. So we need all the different institutions which are present here today. We need it in accreditation, but the very basis, I think, is, and this is a huge task for the future, to understand on a metrological basis these systems of sensors and different measurement devices.
Well, thank you all. We are within just a few minutes of the top of the hour, so I want to again myself thank all of the participants in this opening plenary for some wonderful presentations. I've learned a lot already. As Mary pointed out, I'm an astronomer, so a lot of this information from the metrology community and the quality community is still somewhat new to me, so I've been learning a lot. I want to also, before I hand it back to Mary for her final words, just on behalf of the expert group and the organizing committee for this workshop, we've been working together for a year to bring this all together, and it's really so gratifying to have something like 500 people listening into to the conversation today. That's just astounding. I hope to see many of you in the continuing days, and with that, Mary, I'll let you have the last word.
Thank you. Okay, right. Thank you, Philip. Thank you very much. Now, before I sum up and tell you about the rest of the week and how that is going to be structured and what it's going to contain for you, I'd just like to say a few words. I've been asked why I keep working despite the fact that I'm retired since 2018. And my answer to that is that the day my intellectual curiosity dies, I think I'm ready to die myself. And today has been a day that has really satisfied every single cell in my brain. So thank you all very, very much for that. Now, this was today. Now, can we take the next picture, please, Philip? Thank you. Now, the following 2 days, we are looking at a slide for day 2. The following 2 days will cover a number of strategic topics which will be discussed. There will be presenters like today who will give you background information and give you news and developments. And then there will be a session just like today where there will be an opportunity to discuss. And this will sort of, help you come to whatever you want to give for input for the CIPM strategy for 2030 and beyond. So it's things like global data science and the metrological quality infrastructure and challenges and achievements that have been made. Now, these will be in varying time zones. So when you're logging in, make sure that you choose the right time zone and the right day. If we take the next one, please, Philip. Yes. Now, in the on day 3, we're still on to discussing strategic topics. This time, it's just like one of the questions was regional metrology organizations and national metrology organizations obviously make those up. What type of development it will be in the future? Industry and unit representation systems, views and challenges and achievements. And I think maybe some of the answers to the questions put today might come out of these 2 days, day 2 and day 3, during the discussions. So remember also, these will be repeated in different time zones, and there will be some, so you will have the opportunity to join whatever time zone you are feeling most comfortable with. Next one, please. And on day 4, that will be the more hands-on workshop part, I guess you could say. There will be parallel sessions, and these parallel breakout sessions on the SI core representations on FAIR data, calibration data, and data ready for artificial intelligence. And the sessions will include open discussions with the panel speakers. So here also, join according to which slot and area suits you best. And please make sure that you contribute, because that is what CIPM is asking us to do. And finally, day 5, please. Thank you. That's when we wrap everything up. So during the wrap up, you'll be given a summary of all the discussions that have taken place, the outcomes, both from day 1, 2, 3, but also from day 4. And there will be roundtable discussions of the leading representatives of the organizations of the quality infrastructure. Now, if we take the next slide, please, Philippe, maybe that would jog the memory of everyone as to how to select yes, where to go on which day and how. And finally, I'd like to finish off number 1 by thanking the arranging committee to even considering me as a chair. And I'm very happy that that happened. I learned a lot, and I thank you all for the confidence you put in me for today. I won't be participating in the rest of the events, but I really look forward to seeing the results and looking forward to seeing the strategy that you will be putting together as a result of the outcomes of these days. Thank you all.